I'm Troy Jordan with QuickSound.com. I'll be going over some of the features that a server administrator would need to understand in order to properly set up and run the audio server made by QuickSound. So first of all, I'm going to go ahead and launch the QuickSound server now, fresh. This is running on Mac OS M1 computer, and this is the basic UI. There's not a lot to it. You have the ability to stop and pause the audio broadcast. There are some settings that when you click this, it launches a settings window that looks like this. And then when you are playing audio, you can, I'll go ahead and play some here for you. You can turn this on and see meters of the channels that are receiving audio. I also want to point out to the right, this is some logging information that comes from the server. It's actually coming from the part of the server that is receiving the audio as opposed to the part that's transmitting over the network. And the information about the network and what's being streamed is over in the lower left corner. The information about the data being received from the audio engine, and then how some of the internal buffers, things like that, are being managed is here. This is mostly for troubleshooting. You shouldn't normally need to look at this, but I have it here so that if ever I'm on a phone call with somebody and I may have some questions about those numbers. Couple details here. Obviously, I can pause the audio broadcast, and when you see that I do that, these numbers stop. The logging information stops because there's no new activity happening. What's really happening behind the scenes is the part that captures audio from your audio system, which in this case I have a Mackie 32 channel DL32 system hooked up for testing. That part of the program actually is completely being stopped. And then when you hit start, it's actually starting up a brand new service that's embedded within this control UI environment. So that's that individual component doesn't really have a UI. The only output it has is logs, and then of course the data that it sends over the network and the data that it sends to this monitoring screen. That, you know, when you turn this on, this essentially is using the same monitoring tools that the player uses, except for this is a Mac OS software, not an iOS piece of software. So I want to get a little bit into these QuickSound server settings. I've got this set up to where on your screen, you know, this, when you first open this window up, it kind of comes in slightly underneath the other one. This is probably room for improvement on the UI here. It's very oriented toward somebody who's comfortable with you know, inputting parameters accurately, and you know, there are a couple features here that are, you know, most commonly that you would want to use. One is, you know, labeling the channels and enabling the channels. So enabling a channel, first of all, obviously you can check or uncheck a channel. There are 28 assignable channels. This software supports a 32 channel system, and of those 32 channels, you can assign any 28 channels to be used at a given time. That might improve or be increased in the future, but right now I'm trying to keep it to where I've tested it successfully and not had any, you know, negative side effects, or was able to manage the negative side effects, I should say. So, so this is probably the main area that changes would take place. But over on the left side, we've got these key value pairs. When you first initially install the QuickSound server settings, you might not see anything populated here at all. And that's a little bit of an oddity, but all you have to do to get past that is just save the settings and then close the audio server down, restart it, and then it should populate the bare default values that you see here, which, by the way, looking at my screen right now, is not a bad, you know, it's not a bad set of defaults. Obviously, if you don't have a DL32, Mackie DL32, you're going to put at least one part of the name of your server in here. And the way you would do that, so if you go on a Mac, you can open up the MIDI, you know, audio MIDI setup, And if you open Audio MIDI Setup, you can see the different devices. I happen to have a Scarlett, which is a Focusrite product, and then a DL32. I've tried a lot of different gear out, and I've used a lot of different audio interfaces through the years, but you may have something that I haven't tried yet. Now, when I initially developed this software, I worked with 44,100 hertz. And I don't know why I started that way, because I ended up at 48,000 and found that, just I was kind of fighting myself with using the 44.1K. So it's standardized to use 48,000. You can see my DL32 is named DL32R. If I type Scarlett in there, or if I type, you know, a unique part of one of the words of any of these sound devices, it'll find a match on that partial match. So in other words, if you happen to have two things named DL32, you could put a little bit more information in there and it would match the other one. It's just going to do a contains field match on the name that you choose, and it's going to use the first thing that matches the text that you put in there. Okay, so now the primary job of the QuikSound server is inputting channels of audio and transmitting them over network via UDP. So you might wonder, why does it have output channels? Well, what that's actually for a test situation. So if you wanted to do a loop back test directly back to your system here, you would do that. But probably the important thing here is when you initialize your audio system, most of the time you need to have a legitimate, the number of out channels here needs to legitimately match whatever audio source you've chosen. And it so happens on this Mac, the speakers, if I can get back to the audio MIDI settings. Yeah, so you can see on this MacBook Pro speakers is the name of the speakers that I'm using right now. That's named differently on different versions of the Mac. Anyways, so but it's got two outs, and so I just matched that just to make the audio system happy. I didn't want to hard code that in because you may have a situation where you're going to actually use more outbound channels. I'll give you a couple of examples of that later. The sample rate, you're pretty much going to want to leave it 48,000. You can experiment with other rates, but I could tell you're going to see strange pitch shifting. But if you run into a situation where you're using hardware that's forced to use 44,100 sample rate, you can try that. I suspect we may have to do some collaboration and tune that up, because everything has kind of been factored to rely on 48K at this point. The bit depth, I found that I get good quality just using 16-bit, even though the sound cards or the sound devices oftentimes have higher bit rates they support. Looks like within the Mac OS audio drivers, things like that, there must be some, conversion happening there. But 16-bit for this program seems to work pretty good. And then I default to 128 buffer frames per channel. And that number, you could play with that, but I would keep this number in mind because it's the one that we've had the most successful testing with. These additional settings, let me see, what do we have? We've got, I'm going to skip past a lot of these test settings for a second. Frame sets, you're usually going to want to leave that to 1. You can experiment with increasing that number, but right now it seems to be working best with 1. Throttle. The throttle is an interesting thing because sometimes you can end up with a race condition, and you could experiment with the throttle if you're running into something that's peculiar. But for the most part, you're going to want to leave it just at 1. And by the way, that 1 represents 1 microsecond, just to give you an idea. It's a very small impact. There are a couple places in the program that are impacted by that if you change that number. But I just leave it at 1. Putting it at 0 is not a good idea because there are things that go wrong when you try to calculate 0 seconds, you can imagine. So leave it at 1 unless you have a good reason to be throttling the app. It can be used for experimenting to see, for example, if you had a powerful computer and you wanted to, throttle it to see how it would behave if you had a bunch of other software running. That's one example of how that could be used. Use LZ4 compression. Most of the time, you're going to want to leave this set to true. But if you're running with just a few channels of audio, say, maybe 8 channels of audio, and you don't have a lot of data going over your network and you've got a strong Wi-Fi situation, you could potentially, improve your CPU performance both on the server side as well as the player side by setting that to false. But when you have more data being transmitted over your network, this is going to make a huge difference as far as the reliability, not oversaturating the device. And then self-launch should be set to true. And right now, that's the only supported way that we're distributing this. We could split out the part of the software that does communication with the audio system. And if we set that to false, then this control system is going to expect that other component to be installed. But what we've done is we've actually, with quite a bit of effort, took that C++ application and refactored it so that it could live inside this Objective-C application as a library. So the self-launch is what you're going to want. If I ever ask you to change that to false, it's because we've also installed some other components on a computer for you. Okay, so I think I went over most of these things. The UDP port, if you change that, I don't recommend changing that. And here's why. There's been a lot of testing done with it at that setting. That said, it should be able to be changed. If you happen to have a device on your network that uses that UDP port, you could change that. You could also change the UDP IP, and I think that might be a safer bet. But again, not a huge amount of testing because I've not run into conflicts between this particular port and this particular IP. The IP is not hugely original, but between the IP and the port, this may be an area that more testing is needed if you do run into a problem and if you do have to use a different UDP port. If you're not familiar with UDP, it does not have any package guarantees. It doesn't. It's just kind of like if you had an AM/FM radio and there's a broadcast tower broadcasting a signal. It's kind of like that over your network, but meaning that all the devices on the network can receive it if they're subscribing to that UDP IP and port combination, but your server doesn't have to send all of that data to each device. It's just being sent out across the network, and anything that wants it can get it. So that has some performance advantages. That's the reason we went that route. Obviously, the number of input channels, that if you're only going to use 16 channels, even if you have a 32 channel system, I recommend dropping that down to 16 because you're just going to get better performance. So, you can tune to your needs. You could set that to 32 like I've got it, and then pick out whichever 28 you want. But I would recommend, like in this case, you could see I've got a bunch of stuff that's unlabeled. That kind of indicates that those are things that are not being used. I would go in, realistically, and probably disable all of those unless I knew that, like, something that I've, got a plan for it. There's really no reason to have all those enabled unless you're actually using them. So that's my recommendation. Now, finally, let's talk about some of these strange things in here. So do loop back, test extract. We've got all these different tests in here. These are all tests that I left in the system so that we could do specific diagnostic tests. For example, if you're getting audio, like you're seeing audio through the audio indicators over here, and you're maybe even seeing signs that stuff's being transmitted over the network, but you're concerned that maybe the audio capture system itself, there's something faulty there. Like if you're having noise, what you can do, there's a couple things you can do. One, you could change this test extract to true. You just have to type that in as true. and then that makes all of these other items that come after it possible. So you could you could say, I'm just going to extract the audio, and I'm only going to extract the first two channels. Okay, so it's not summing and mixing all your channels. That particular test is just going to take channel 1 and channel 2, which are labeled keys L and keys R on this system. It's just going to take those two channels and return it back to whatever you have designated to be the output device. So it's almost like a loopback, similar to a loopback, but the difference, a loopback would only, a pure loopback, like up here where I have do loopback, if you set that to true, that's only going to work if you have the same number of input channels as output channels on your system. So that's a big distinction, right? So in other words, there's a mismatch between my input channels and my output channels. Like that, 32 input channels, 2 output channels. So if I try to do a loopback test, I'm going to get tons of noise because it's going to try to take the 32 input channels and output it to 32 channels that don't exist. Now, if I made my output device instead of speakers, if I made it be the DL32, it still wouldn't work because it so happens the DL32 does not support 32 outputs. It supports 32 inputs and I believe 16 outputs. But if you happen to have a device that has the same number of inputs and outputs, you could do a loopback. So in that case, you'd have the same number of channels. You'd set it to true, and you could just do a loopback. Well, that's not going to be the case most of the time for most people. So this test extract, if you're wanting to do that kind of a test, you can set test extract to true. I'm going to skip over these first two. They're kind of esoteric. They're probably going to go away in the future. But this test extract first two is useful because you can have 32 channels of audio set up, and then have signal coming in on the first two, 1 and 2, and then get those to play back through your speakers just to make sure that there's not something funky going on with the way the audio is coming into the system. So that's a handy testing tool. And then the other one is, the next one is similar, but a little bit different. And it's test extract first in. Now what that means, whatever number of input channels you have designated here, it will attempt to take those channels and output them to an equal number of output channels. So if you had a 8-channel audio system and, if you had a channel, let's say, okay, we've got 32 channels on the Mackie DL32, and let's say it only supported 16 outs. I could change the output to 16 here, and then I could go down here and say extract first in, and then change the input to 16 as well. And what it will do is it'll take the first 16 channels and output those into your 16 channels of output. So it's another type of almost like a loopback test, but it's kind of a way around the fact that some devices have a different number of input and output channels. So that's the purpose of that. Probably not going to need it, but if you ever do, that's what it's used for. But for either case, you could have one of these set to true right now. Test extract is set to true. I would set that back to false by default. But it takes a combination of test extract being set to true and one of these others also being set to true. So like if I had this set to true, but test extract is set to false, it's not going to actually run that test because this is like kind of like a parent property that controls all of the following test properties. Okay. So I typically leave all of those set to false unless I'm specifically using them. Now, this testing stopping point is pretty esoteric. There are a few places in the source code that look at this value, and if the value matches a testing point, it will exit the program there, essentially. And you may wonder, what is the purpose of that? Well, the purpose of that is to isolate when there is a problem. So I'm going to show you a little bit of what I'm seeing, in the logs right now. So these are some of the logs for the server. Whoops, it's not letting me show it to you there. So I happen to be launching this from Xcode, but if I were to launch it from, just the app icon, I wouldn't see those logs there, but there is a trick, and I could show you that trick of how to get to where you can see those logs. All you'd have to do is on a Mac, you right click, you tell it to allow you to see the details, and then under the Mac OS portion of that application, there's a terminal program in there, a command terminal program that you can run, and then you'd see all the same logs I just showed you. So there is a workaround there. Hopefully you won't need to get into that, but I may do a separate video on just that. So those are the main settings. You can refer back to this screenshot just to kind of give you an idea of what normal should look like. I didn't really change anything. All of these settings should work. I'm going to launch a player just to make sure that everything still works. So give me just a second here. Find it. It's fun when you're doing these tutorial videos, you can lose track of where all your screens are at. All right, so this is going to run in a simulator. This is kind of interesting because the simulator it doesn't like my orientation, so I have to kind of flip it around. There's also an orientation change button right here so that you don't have your orientation in the player just randomly moving around on you if you happen to move your player around in your hand, your iPad. So let's just check this guy and see if it's still working after all this stuff I did. So it's running there. Okay, so it's still good. Got our meter still running. And sometimes when the meters are running, you'll hear little warbles, so people complain about that. You can kind of advise them to shut the meters off. And then I'll just show you that when we pause the data on the player, we immediately stop receiving packet data over here. Let's try starting again, see what happens. And that kind of went off without a hitch. That does not always happen. It's not always the case. But there's been a lot of work putting into solidifying that and hardening it so that, when you pause the audio broadcast, it doesn't create noise for the user. That was something very, very important to me, that we not blow somebody's ears out. And then when you restart, it starts up smoothly. And those are kind of things we take for granted, but when you engineer a product like this, those things don't come for free or by accident as far as from a programming perspective. All right, so that's an overview of the server administration. I'll probably do a separate video on, actually the topology and, how to set this up. Right now, because I'm doing a demo using, this is a simulator, it's basically local host testing, so I don't have any concerns about bandwidth, those kinds of things. But I've done thorough testing with a multitude of devices. I've got a iPad Pro that I've tested across Wi-Fi. I've tested this on M1 Macs running the iOS version of the software in kind of a auto convert mode, and that seems to work fine over Wi-Fi. And then I've got an iPad 12 Pro, iPhone 12 Pro, and then I've got a less powerful iPhone LE or something like that. Those work fairly well. There are some limitations, as far as supportability goes. I do find that the server runs better on an M1 Mac than it does on an Intel Mac, but that's partly probably because some of the Intel Macs I've tested on are kind of old. I have successfully got this server software to run on older Mac hardware, but I highly recommend, if you're going to spend the money, the server software that's going to connect to your audio system is is probably the one piece of gear I would recommend getting something a little bit better quality. You could do it on a Mac Mini. Obviously, you have to have monitor and those kinds of things, and that would work great. But I've been testing mostly with MacBook Pros as far as the server side. Um, so that's a little bit more about that. I think rather than me talking about all the testing I've done, I'll publish more of that information out on the website, which is at QuikSound.com. And if you watch this video and you have any questions, or you think there's something else that should be added here, for supportability, I'm very interested. Supportability is very important to me. I have a background working in enterprise systems and healthcare. Obviously, have an interest in audio engineering. Went to the University of Missouri, Kansas City Conservatory, studied audio engineering a long time ago. And then got serious about computer programming along the way, and had a extensive IT career, and decided in 2024 to launch and kind of relaunch an IT business and doing software engineering. So I hope you've enjoyed this video. Feel free to reach out to me personally if you have any questions. You can. I'm still, going to be working on how to best get feedback from clients and people who are interested in becoming clients. So hopefully soon I'll make that easier for you to do. I want to have some systems in place that do things like have features listed and give you the opportunity to vote on which features you think are most important, or which areas are the biggest problems that need to be fixed. I want to try to create a system that allows me to partner with the people who are using the software so they get the best results possible. I wish you a blessed day. Thank you.